Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Welcome back. Have you ever looked at a fan or a water pump and wondered, what exactly makes the motor spin inside? It actually comes down to a simple magnetic force. Today, we are going to solve an important exam question that unlocks this exact secret. The question asks us, first, to state Fleming's left-hand rule. Then, we need to apply this rule to find the direction of force on a straight current-carrying conductor in a magnetic field. We'll also see what happens if an electron enters this field. Let's start with Fleming's left-hand rule. Imagine stretching out the thumb, forefinger, and middle finger of your left hand. You need to hold them so they are mutually perpendicular to each other, just like the three corners of a box. Now, here is the trick to remember. If your forefinger points in the direction of the magnetic field, and your middle finger points in the direction of the electric current, then your thumb will automatically point in the direction of the force or the motion of the conductor. Look at the 3D diagram on the screen. See how the fingers perfectly align with the field, current, and force. Try doing this with your left hand right now. Excellent. Now, let's apply this. When current flows through our conductor in a magnetic field, the conductor gets physically pushed, causing a displacement. This proves a magnetic force is acting on it. But what if, instead of a wire, a negatively charged electron shoots into the magnetic field in the exact same direction? Interestingly, it will experience a force in the exact opposite direction. Why does this happen? Well, in physics, the direction of conventional current is always taken as opposite to the flow of electrons. Since the current direction reverses, the force reverses too. Did you catch that? It's a favorite concept for examiners. I hope this makes Fleming's left-hand rule super easy to remember. Practice this with your hand a few times. Thank you for watching and happy learning.